The subject name is Compiler Design. I, Dr. Sivaji. Last class we discussed about some of the concepts which are related to the problem solving with related to parsers. Now we are going to give a brief overview of different types of parsers, CLR and LLR parsers. CLR and LLR. Previously you have seen the computations of first follow functions. So in the to calculate the grammar is whether this grammar is a LL1 grammar or not. So based on the entities which we defined can be verified with the help of the calculative functions first and follow. So we have to compute the first function as well as follow of the defined entities. So this is to be described with the help of the parse table, where parse table can be implemented. A parse table will be implemented with the help of set of rows and columns. Here rows are described with the non-terminals, that is called as variables, and the operators that is to be used, identifiers, plus, star, left bracket, dollar, that is to be. So after computation, each the entities are to be defined with the particular each cell, where the computations are to be described. So that is to be mentioned in this one, in the table, and we are going to identify whether this contain. And so in this example also we discussed about entities are multiply defined entities, then we can say that it is not a LL grammar. So that it is very important to know that. Now in case of LR parsers, LR rightmost derivation, left to right. So here the grammar is to be specified. For example, here we have taken one example. In this example, the given grammar is S derives A, and another one is A derives small a capital A, and another one is A derives. Now the argument we are going to add in this for calculation, we are going to use a canonical production of LR of 0 items. What is canonical production of LR of 0 items means? We are going to, in this calculation, first one is the production of the start symbol which is available in this given grammar. We are going to add a argument production. We are going to define an argument production, that is S dash. S dash which is defined with S. Now we are going to add the remaining productions which are given in the given defined grammar. So S derives capital A, and one more derivation, capital A derives small a, capital A, and B. So this is the defined. These are the productions which are to be included for the canal. So in this one, we are going to add a dot symbol for each of the productions. Dot at the beginning of the production. So here the two productions are combined. So that's why we are going to insert dot at this place. So like this is to be called as first step, canonical collection of LR of 0 items, that is inserting argument production. By inserting argument production which is the symbol that is to be identified from the beginning of this. Now we are going to find out I0. First I0. So what is the closure of this one? So that means for all productions, what is the dot symbol that is followed by non-terminal. So what is the non-terminal? It is following. Add all productions with A in modified I0 state, and I0 is followed by non-terminal. So the state becomes this is the I0. This is the given production I0 closure of S. So that's why this argument production to be added, and the given productions S derives dot A and A derives dot A, and this is argument production. These are the production which computes the I0 state. Now from I0 state, I1 is to be computed. So we have to consider that one as I0 state. From that I0, we are going to compute a state that is to be defined, that is to be defined as named as I1. In this, we are going to calculate that is closure of this one. What is the closure of S? So I naught, this is to be I naught comma S. So this I naught S to be defined in such a way that what is the production that is to be reduced to the closed state. That means previously S derives S dot S. Now this dot is to be a one, one symbol ahead. So one symbol ahead means one symbol after symbol we are going to keep each every time one symbol ahead. So that's why here we are going to get S derives S dot. This is I naught comma S. I naught comma S. So like this we are going to perform this one. Similarly, we are going to perform I naught comma A. I naught comma A. So what is the previous one? S derives dot AA. So if you perform I naught comma A, S derives A dot A. S derives A dot A. Why? Because previously what is the production? Previously S derives dot AA. Now this we applied this augment production that is reduced to the closed state. What is the closed state here? A dot A. Now once again this is a state. This is the state that is I1 is the state which we consider. Now this is called as I1. Now this is I2. I naught comma A, that is a new state I2. Now in I2 also once again we perform until this reach out. So that's why here I2 once again with capital I2 with small a, I2 with small b. So I2 with small b, what happens? With small a derives the dot AA production. So that is after implementing, that is A derives small a dot one symbol head. So that's why A dot capital A. Now here there is only one symbol is available letter. So that's why A derives it automatically A derives B dot. So it reaches the end. So from that there is no. So that's why here whatever the states it is not completed, that is to be processed till it is completion. So here I2 with small a, small b. This is the I2. Once again we perform small I2 with A derives A dot capital A derives B dot. So these are the three productions which we reached for this case of I2. That is I2 with A, I2 comma B, and I1 with A. I2 with A. So now I3 once again we perform with I3. So that is here A dot A, small a dot A. So that's why here from this once again I3 is not completely ended. So that's why once again we perform the state I3 with I naught comma A. So we are going to get this one. Now once again I3 comma A we appears this one. Then I3 comma B dot. So these two things which you perform in this example. Now I naught once again we perform for I4 also. I4 means here I naught I1 I3. So A derives B. A derives B. So here A derives B means B dot. Here it is completed. Now I5 also it is completed with S. A derives I6. It is also A derives small a dot A, and from this we are going to get A derives small a capital A dot. So it is reached the dot. Whenever dot is reached at the end of the production, then we can complete the process. So that is there to be written with the help of a diagram. So in this graph, to be represented with the states I0, I1, I2, I3, so on. So what are the given productions? S dash, this is the augment production which I have considered, and given production as S derives dot A, capital A, and capital A derives dot small a, capital A, dot B. So these are the capital A derives dot B. Now these are the given productions. These are the given productions in the example also. So example, so here we have considered the augment production. This is the completely we can call it as then state I0. This is the given productions, which are from there we are going to generate I1, I2, I3. So in the flow graph also we can depict easily how this I1, I2, I3 can be generated. So in this one, what is the S? So here we are going to perform. This is the state I0. So I0 comma S capital S. So if you perform the production with this I0 comma a closure of this S, then what we will get? S dash derives S dot. So this is the state that is generated. S dash derives S dot. So this is the end of the production. But if you take I2, so how to get the I0 comma capital A? Here I0 comma capital A means what are the productions which contains A? So this is the production which contains. So this is already completed. Now second one we are going to take, that is I0 with capital A. So this capital A performs with the dot production of this previously what dot AA. Now we are applying one symbol head, so that is A. So S derives A dot capital A. Now what are the productions which contains A after the terminal? After this verify whether it is a terminal or non-terminal. So here it is a non-terminal. So what are the production? If it is a terminal, we won't get the productions belongs to that one. So simply we can skip that one. But in case of non-terminal, we are going to apply the case once again. What are the list out productions? So that is capital A, which derives. See here, these are the two productions. So that's why here dot A and one more the A derives. So these are the three that is to be included in capital A. Capital A. Now, if you observe this, only two productions are available. That is small a and small b. So we can perform two cases: I0 with small a and I0 with small b. So I0 with small b, if you perform, we will get A derives one dot ahead. So A dot capital A. Now, what is this? What is the symbol that is available? Capital A. So, what is capital A productions which are related to this one? So, these two can be follows. Once again, that is A derives dot small a capital A and A derives dot B. A derives dot B. Now, these three can be as a new state that is called as I3. So, this is the state I3 that is to be generated. Now, if you come to the next I0 perform on B, what is the state? See here, A derives dot B, that we are getting B dot. But here, if we observe these, what are the symbols which are available after the period dot? There are no symbols. So that's why we are going to stop this one and make a new state. So that is the state called as I4. Now from this generated states, so what are the states that is to be generated till now? I0 is the first starting state which you consider, that is closure of items. Now closure of items I1 we performed, I2 we performed, I3 and I4. So in I1, what we get? S dash derives S dot. So this is the production that is available. So in this, the dot production is reached the end, and from that there are no further symbols are available. So it can't generate any new state. So it stops the process of generating the new states. So until that we are going to repeat the process for completion of this. So that's why the states are to be increased as per the given production list. Now I1 is completed. And if you observe I4 also here A derives B dot. So after the dot there is no, so that's why it is also stops the process. Whereas if you consider A2 and A3, I2 and I3, these two are not stopped. So it contains the list of the remaining productions also. So we can continue further with the remaining states with I2. For example, if you take I2, what are the productions that are available? S derives A dot A, capital A derives dot A, and capital A derives dot B. Now, in this state, we are going to apply, we have to apply I2 comma capital A first. So if you apply I2 comma capital A, that's why here the state is I2 and the transition supplied is I2. So what we will get, so here S derives one period ahead means, that means following this one means capital A dot. So it reached the end. That means after this there is no other symbols which exist. So that's why you can name as a one state that is considered as I5 state, and we can stop this I5. But what about remaining also? That means I2 comma small a also you have to compute, and I2 comma small b also, small a and small. So if you compute I2 with small a in this one, so what we get, A derives small a dot capital A. But here after the dot the computation, once again the non-terminal exists, then we have to include the related A the productions also. So that's why A derives dot AA and A derives dot B. You have to copy. So that's why these three, which is same as the productions which are available in I3. So I3 also contains. So instead of writing a separate state, no need to write the separate state. Why? Because A derives A dot capital A derives dot small a capital A, and A derives dot B. So these which is same as the list of productions available in I3. So instead of writing if you write the new state, that is suppose I4 exists, I5 completed. Now if you write I6, then the duplication, no need to write the closure of items with the same derivation twice or thrice different times. So that's why instead of writing this state, we are going to give a transition path. That is here what is we calculated I2 comma IA. So that the state I2 and the transition A which leads to the computation, that is same state I2. So that's why we have given a transition path as it. So it is sufficient, no need to write separate. So suppose if the derivations are different, then we have to compulsory write a separate mentions. And next one is I2 comma small b. If you apply I2 comma small b, then I2 small b means A derives will get, so if you apply this one, we'll get B dot. But here, see if you observe this B dot already existing in one state, that is I4. So that's why there is a transition arrow mark following with B, A derives B dot. So that's it is no need of writing a separate state. So this includes the transition symbol with B. So that completes the I2 comma A and B. Now we can perform the computation for the closure of items with I3 state. So I1, I2, I4 is processed. Now remaining leftover one is the state I3. Now I3, if you observe the state productions around A derives small a dot capital A derives dot small a capital A derives dot B. Now here in this one, now we are going to apply this I3 comma capital A. I3 comma capital A, then the derivation which can be computed as A derives small a capital A dot. Small a capital A dot. Now the period is dot operator is reached at the end point. After that there are no terminals or non-terminals exist. So we can stop. So that's why you can make it as it is a new state, that is I6. So from this we can make an arrow, and the state is I3. So this is the state. From this state we perform taken closure of A, and closure of A reached to the new state. What is the state? I6. Then we can also write this is not completed, only one derivation is completed. Now one more, that is small a and small b also available. So I3 comma small a. Then if you perform, we'll get a derives small a dot capital A. So after the period, what is exist? Capital A. Now what are the derivation that is exist for capital A? Capital A dot with small a, that is reaching dot small a capital A, and A derives dot B. Now these three which is available with the same, that is I3. I3, the list which is available in the productions are available in the same state I3, and also which we got A. So it is considered as a self loop. So we can make a self transition here, and with the A transition symbol A, we are going to use these productions with the same state instead of writing a separate. If you are writing the separate state and producing, then there is a repetition. So instead of avoiding that, we are going to make a self loop and attaching with the symbol, that is input A. Now what is the leftover? This is also completed. Now it is the third one, that is I3 comma, what is here? B, small b. So if you apply the closure, then we will get A derives B dot. B dot. Now this is the production B dot. Now this is already available, that is A4. So that's why we are going to make the B. Here previous one is B here, I2. Now this is I3. I3 state 2. Previous one is I2 comma B. Here now it is I3 comma B. I3 comma B means this one. I3 state I3. State, this is the I3 state, and performing the closure of operation and reach to the state A derives B dot. So this is the I4 state instead of writing. So if you observe the remaining all states, the input processing, that is closure of items, are to be calculated as per the requirement, and it is the end of the period reached to the end of each input. That is, for example, in case of I1, we have processed and reached this one. In I2, it is not processed. That's why we reach to the I5 state, and remaining it is computed with the transitions. And for I3 also, we reach to the I6 and we computed with this one. And I4 is already I1, I4 previously starting closure itself it is completed. Only we computed this with I2 and I3. So if I2 with some closure operations, capital A we reached. So here I5 reached end, so that's why we stopped. I6 it is also. Now after completion of this one, we have to write the parse table with rows and columns, where the rows are to be described with the states. So how many states we got? I0 to I6. So the I0, I1, I2, I3, I4, I5, I6. So these states can be written as a row wise I3, I4, I5, I6. Now we are going to write a columns with two columns. One is action column, another one is go to. So what are the action column is denoting this? What are the terminals that is available, and what are the non-terminals available in the given. So here in the given means in the given productions, what are the, that is small a, small b. These are the terminals which are available. So that is to be considered as a part of action. And what are the non-terminals? Capital S, capital A. So that's why these two are to be considered as good. These, like that, two sections are to be divided in the column. And for this we are going to compute, we have computed what is I0. In the first state if we observe, I0 with small a. Capital S and capital A we already computed. What is I naught with capital S? So in this diagram, I naught is the state and capital S closure, and we reach to the state 1, I1. So that's why I have written it is a 1. And I naught is the state and capital A with closure, we are reaching to the state I2. So that is the number. This number indicates that what is the state that is to be reached. And what is the that is go to, and what is the shift is to be performed. So I naught with small a. So like terminals I naught with small a. We have reached to the state that is here we are going to write a shift performance because this is a shift S3. Now small b also shift S4. So these two total 4. Remaining like that I1 also. So here I1 is the last end state. That's why we have included a dollar indicating that it is to verify that acceptance of the states completed by using this one. So dollar is also to be included as part of this one column, and where the starting of the symbol denoting that acceptance of the given productions. So I1 that is to be considered as acceptance state, and next I2 also with capital A. So we are going to perform I2 with I2 closure of capital A, I2 small a, and I2 small b. So capital A is reached to the I2 with capital A reached to fifth state I5. So that's why I have written 5. And whereas small a, I2 with small a, that is reached to the I3. So S3 and small b S4. So these are the two combinations which are used for the I2 state. And similarly for I3 with small a, capital A, small a, and small b. So these are the three closures which we found. So I3 with capital A reached to the state I6. So that's why here 6. And I3 with small a reached to the same. So that's why S3. I3 with small b reached to I4. So S4. So this is the shift operation to be shift performed, and go to is performed with the non-terminals. So and then I4, I5, I6 if you observe. So here I4 is the state which is completed. After the from that there is no some. I5 is also state which is performed. I6 it is also state which reached to the end period. So these three can be written as it is I4. What is this computation here? I4 is A derives B dot. So this is the reduction to be completed R2. This is R. So here A4 production is A derives B dot. So this derivation, derivation exists in the. We have to write the reduction steps with the numbering 0, 1, 2, 3 like this. So augment production is 0, remaining 1, 2, 3 like that we have write. And where this A derives B exists in which direction. So that is what is R3. So that's why the I4 is to be written with R3 for all the action parts. And similarly I5 contains the production S derives A dot. So that is to be yes R1. So that R1 is to be included action part of the 3. Then similarly for next one I6. I6 is what is the production that is available in I6. So this state contains derivation that is A derives A small a capital A. So this is the where this reduction exists R2. So that R2 can be included as a part of action for this. So like this we are going to implement a parse table mechanism. That's the LR parser is to be implemented with the closure of the all items. So simply we are going to find the clue. First initially add augmented production with the dot, and then we are going to list out the corresponding. So this is the Next, we'll come up with another parser notation, that is CLR and LLR parsers are also can be implemented with the help of this parse table implementation and flow graph. Thank you. We'll come up with this one.
Like, share and subscribe. Hit the bell icon for more updates.